Welcome everyone. This is Docker Part 8, in which I will be covering Docker Swarm with the short demo. And if you like to see my previous parts, please visit to SciEmpathX YouTube channel. You will be able to see my previous parts in which I have covered Docker from very scratch. I have explained the difference between containers, VMs, volumes, networks, container lifecycle, and so on. So let's get started. I will start presenting my screen, and we have very short PPT today. I will be covering more of demo part. So to start with, what is a SOM? So SOM is nothing but orchestration tool or cluster management tool that is there embedded in the Docker engine. And you can use SOM kit as well as a project which implements Docker orchestration layer, and it is used directly within the Docker. So basically, SOM consists of multiple Docker hosts which run in SOM mode and act as managers and workers. So I will be showing this part to you in a while, that how you can create a manager and how you can assign a server IP as a manager and the others as workers. A given Docker host can be a manager, a worker, or it can perform the both roles as well. So when you create a service, you define its optimal state. The optimal state in the sense the number of replicas, network, storage, resources available to it, ports the service exposes to the outside world, and more. Docker works to maintain that desired state. So for instance, if a worker node becomes unavailable, Docker schedules that node task on another node. A task is a running container which is a part of a SOM service and managed by a SOM manager as opposed to a standalone container. Here, one of the advantages of using SOM is over the standalone container is that you can modify a service configurations, including the networks, volumes it is connected to, without a need to manually restart the service. Docker will update the configuration, stop the service task with the out of date configuration, and create new ones matching to that desired configuration. When Docker is running in Swarm mode, you can still run standalone containers on any of the Docker hosts participating in the Swarm, as well as Swarm services. Key difference between standalone containers and Swarm services is that only Swarm managers can manage a Swarm, while standalone containers can be started on any daemon. Docker daemons can participate in Swarm as managers, workers, or both. So coming to the PPT, as I have already covered, the Docker Swarm is a container orchestration tool. Docker Swarm is a group of either physical or virtual machine that are running the Docker application and that have been configured to join together in a cluster. A swarm consists of multiple Docker hosts which run in swarm mode and act as manager and workers. And to explain you more about Node, so a node is an instance of Docker engine participating in the swarm. You can also think of this as a Docker node. You can run one or more nodes on a physical computer or cloud server, but production swarm deployments typically include Docker nodes distributed across multiple physical and cloud machines. To deploy your application to a SOM, you submit a service definition to a manager node. The manager node dispatches units of work called tasks to the worker nodes. So manager nodes also performs orchestration and cluster management functions required to maintain the desired state of the SOM. Manager nodes elect a single leader to conduct the orchestration task over here. Worker nodes receive and execute that task dispatched from the manager nodes. By default, manager nodes also run services as worker nodes, but you can configure them to run manager tasks exclusively, and you can mention those servers as manager only nodes. And agents run on each worker node and reports on the task assigned to it. The worker node notifies the manager node of the current state of its assigned task so that manager can maintain the desired state of each worker. Now, I will be going to do is I will just cover few of the features which Docker Swarm have feature highlights. So these are the listed features. So it is having a cluster management integrated with Docker Engine, decentralized design, declarative service model, scaling, desired state reconciliation, multi-host networking, service discovery, load balancing, secure by default, and rolling updates. So what I am going to do is I will show you a Docker document over here. so that you can also go through the same document and understand more about these feature highlights, which I am going to read one by one now. If you have any doubts, you can post in the chat and I will be answering them. So use the Docker Engine CLI to create swarm of Docker engines where you can deploy application services. You don't need additional orchestration software to create or manage a swarm. So this is one of the feature of swarm. Then we have decentralized design. Instead of handling differentiation between node roles at deployment time, the Docker engine handles any specialization at the runtime. You can deploy both kinds of nodes, managers, and workers using the Docker engine. So this means you can build an entire swarm from a single disk image. Coming to the declarative service, Docker engine uses to let you know, define the desired state of the various services in your application stack. For example, you might describe an application comprised of a web front-end service with message queuing services and a database backend. So we have scaling over here. You can declare the number of tasks you want to run, or you can scale it up or down. Desired state reconciliation. So the SOM manager node constantly monitors the cluster state, reconciles any differences between the actual state and your expressed desired state. So they have given an example also. I highly recommend please go through this docs.docker.com, and if you are interested in doing Docker certification also, then it is must to go through docs.docker.com. We have here multi-host networking as well. So you can specify an overlay network for your services. The SOM manager automatically assigns addresses to the containers on the overlay network when it initializes or updates. So please go through these features one by one and let me know if you have any doubts. Now, without any further ado, what we are going to do is we will move on to the demo part. So what I'm going to do is I will be using Play with Docker today, and we will be following this docs.docker.com to create, to run these Docker SOM manager nodes, worker nodes. Let's get started. Play with Docker. Please open this docs.docker.com/engine swarm tutorial so that you can also follow. So here what I'm going to do is I will add few instances over here. Let's add 2 more. And then what we are going to do is we will make one node as master. So how to do that? We will be using this command to make one of the IP, one of the servers as manager. So let's paste this and let's copy the IP of this server. So what we are doing is currently we are making node 4 as a master one. So here we go. To add a manager to this SOM, run docker SOM join token manager and follow the instructions. So if we want to add workers to this manager, we need to run the following command. To add a worker to this SOM, run the following command. So let's go and make this node 1 as worker. So here we go. This node is joined as a SOM worker. Let's make this node 2 as worker. Here we go. Let's move on to node 3. Yeah. So we are done. We made node 4 as a master one, and rest all we have here are worker nodes. So getting back to the document, these are the commands. Let's learn more about what this flag do. So this advertise -adder flags configure the manager node to publish its address as 192.16.800. So they have given example as this, and we have a different IP over here. Okay, so the other nodes in the SOM must be able to access the manager at the IP. So the output includes the commands to join new nodes to the SOM. Nodes will join as managers or workers depending upon the value of the token flag which we give. So let's run docker info and let's see whether our SOM is active or not. Let's move on to the master. I'll increase font a little and let's see if our Docker info shows us, let's clear the screen and let's paste Docker info. Let's see whether SORM is active or not. Let's scroll a little up and here we go. You can see here our SORM is active. You can see node ID manager. It is manager is true. Manager 1, we have 4 nodes in total and 1 manager. This is the default address pool. This is the whole information. Now let's move ahead and run this command, docker node ls. This command is to view the information about the nodes. Let's clear the screen and let's see docker node ls. Here we go. So we have information over here, that is your engine version, host name, status, availability, and manager status. So as you can see, our node 4, which we had made as a master, is a leader over here, and rest all is active, ready. This is how we can see. So what's next? Let's add 2 or more nodes to the cluster, which we have already done. So we have performed this step already, and we have joined as a worker. So we have already seen this Docker node ls. Let's do deploy a service. So let's move on and copy this command. So what we are going to do is open a terminal, SSH into the machine, and you can do this part. Let's try doing this. And what we can do is we can increase or decrease the number of replicas in here. So what we are going to do is the docker service create commands creates the service. The hyphen name flag names the service as hello world. Hyphen replicas flag specify the desired state of running instances, and the arguments alpine ping docker define the services and alpine linux. So what we are going to do is now we'll see the services present in our playground. Let's go ahead and just check for the services. Here we go. We have hello world replicated 1 by 1 replicas. Okay, now what's next? We are ready to inspect the service. Let's go and do so. What we are going to do is we'll be running this command, and let's see what output we get in there. So here we go. And let's go back to the document. What it says is to return the service details in JSON format. Okay, we can run without pretty if you want in JSON format. So run Docker service PS to see which nodes are running in the servers. First, let's check out this over here. So what this command has done is it has given us ID, our name, replicas, a very nice output. In here, an image which has been used in it are spin docker and endpoint as well. So now let's move on to the next command, and let's run this docker service ps hello world, and let's check out what it says. So let's clear out the screen and paste this command in here. So this is the alpine latest node 4 running. So it is running at the node 4. So now what we are going to do is we will paste in here docker ps. We will be seeing in here what is the command, pingdocker.com, the name, the image, what is running. What's next? Now we will change the scale for the services running. So here, what is the command to do so? We will change the scale, and let's see how it goes. Let's clear the screen and paste in here this command. So we can see 5 out of 5 tasks are running now. And let's run this command and see where and all the nodes, the services are running. Check this out. Let's see. So these are the images that are services that are running. So in on the node 1 we have hello world 5, node 3 hello world dot 4. So this is how the orchestration is happening using the Docker Swarm. Let's clear the screen and check out what next. Let's try to delete the service. So deleting the service is very simple. Docker service rm hello world. So if you want to remove any service, it is very simple. You just need to execute this rm command in here. And here we go, Docker service ls. Now we do not have any services running in here. Now let's check out the next thing, that is rolling update here. So you can deploy a Redis stack to the SOM and configure the SOM within 10-second update delay. So this is an example which shows you an older Redis stack, and you can configure the rolling update policy at service deployment time. This is how we can do this thing. And let's move ahead. So Docker service inspect Redis pretty. So let's try it out how we can run this. Let's go to the Docker playground and paste the command. Let's see what happens next. Now let's try to inspect the Redis. It is still verifying and waiting for it. Let's clear the screen first. Let's go ahead and paste. Here we go. So we can see the ID, the name, that is Redis, and service mode is replicated. We have 3 replicas in here. Parallelism is 1, and rollback order is stop first. On failure, it is pause. Init, this is image, init is false, and endpoint. So this is how we can inspect. And let's go to the next command. Let's try to update the Redis. So it is updating. It is waiting to verify it. So now after this, let's try to run Docker service ps command and see what's happening in there. So as you can see now, on node 1 we have redis.1, node 2 we have redis.2, node 4 we have redis.3. Let's move ahead and let's try to drain. Now let's learn more about drain a node on the SOM. So in earlier steps of the tutorial, all nodes have been running with the active availability. So if you want to change the availability of the node, so how to do that? This document describes it very clearly. So sometimes, such as plan maintenance time, you need to set your node to drain. Drain availability prevents a node from receiving the new task. So you cannot perform if the node status is in drain status. You cannot perform any activities or new tasks cannot be added to it. It also means the manager stops task running on that node and launches replicas task on the node with the active availability. So if the status of your node is drain, it will not assign any manager will not assign any tasks to your node. If you haven't already opened a terminal where you can run your machine node, for example, okay, so we can verify our nodes are actively running, which we have already done. So we can just execute docker node ls command. If you aren't running the Redis service, but we are already running it, so no need to execute this command. If you have by mistakenly stopped it, then you can run this again. So let's try and execute this command again and see if our services are still running. Yes, our services are still up and running. So what we are going to do is we will try to drain one node in here. So let's try doing that with the node 1. Okay, we have done this, and let's now try to check out the Docker node ls status in here. So let's try doing that, Docker node ls, and then we will be seeing that node 1 which we have drained is now not available for a manager node to assign any task to it. Let's move on to the next command, and let's try to inspect our node 1, what it says. Let's try to inspect it using pretty command. Let's do that, node 1, and here we go. It states that this is the ID and the state is ready, but currently it is in drain status, and the memory, logs, volume, network, everything can be seen using this command. So now let's try and executing this command in here. Now we can see that our node 1 status is shut down. So currently it is shut down, rest all are available, it is running. Okay, now what we are going to do is we will again update the status of node 1 to active from the drained status. So let's do that. Paste in here. And I'm sorry, I forgot to mention which node. Let's do that again. And here we go. I am really sorry, I'm missing. Okay, so now let's check out the Docker node ls command. Let's first clear out the screen and then see Docker node ls, and we can see that all of them are ready. Let's check out for the services. Okay, we have 3 currently runnings, replicated, Redis, once in here. So this is all for today. You can always visit to docs.docker.com. You can reach out to my Twitter or LinkedIn profile if you have any doubts. And you can just follow the documents, follow this tutorial. If you have any doubts, just reach me out. Thank you. Bye-bye.